Hello, you are welcome to Maths Clinic Series. In this video, we are looking at the series of permutations. And the previous video, we did the introductory aspects of the permutations and combination. And here we want to start with the permutations. And by the end of this part of the video, you should be able to define permutation in mathematics, arrange objects or things in a row without repetition, then solve few problems in relation with permutation without repetitions. So like we said earlier on, in permutation, position matters, and so first, second, third is very important to us. Now, before we continue, I want you to predict my secret code, which contains the number 1, 2, and 3. And let me give you a clap for that. Just one number, and then it must contain 1, 2, 3. All right, I'm sure you came with. If yours was 2, 3, 1, that means you won 1. Let's continue. Now, for permutation, we say it's an arrangement of things in order. Arrangement of things in order. Position is required in permutation. Position is required in permutation. So we want to start with permutation without repetition. Permutations without repetition, because we have permutation with repetition. We want to do this step by step so you don't get confused with it. Okay, so without repetition, for example, if I give you the number 1, 2, 3, in how many ways can we arrange number 1, 2, 3? 1 is not repeated here, 2 is not repeated, 3 is not repeated here. Or if I say the word can, in how many ways can you arrange this one? But there's no repetition, so that's what you want to look at first. Okay, so the first thing I want us to consider, I want to generate a formula for calculating or perm without repetition. In how many ways can this be arranged? If I have only a pebble of one color, red, only one, how many ways can I arrange this? I think that is obvious. That is one way, right? No wahala for that. What about I have 2 colors? There's no repetition. I have 2 items, red and green. In how many ways can I arrange red and green in a row or in a line? So that is 2 ways. Okay, so if I decide to make red first, then green will automatically be second. I can also make green first, then red become second. Could there be any other way I can do this? No. So I have only 2 ways in doing that. What if I have 3 colors or 3 marbles with 3 different colors? There's no repetition here. There are 3 and each of them has different color. In how many ways can this be done if position is required? So let's say I put red first, I put green second, I put blue third. I could interchange the position by having red first, blue second, and then third. You see, these are also different arrangements. The first one is not the same as the second one. Then I can have green, red, blue. I can have green again, blue, red. Also different arrangements. So how many have I gotten so far? 4. Then I can also keep blue first, green second, red third, or blue first, red second, green third. Could there be any other way I can do this? And that is all. So here we have 6 ways of arranging 3 items with different colors or different items involved. So look at the word math. In how many ways can the letters in the word math be arranged? Again, you can get your answer. Then let's go detail of it. It can be like math. So it can be like math. Look as if my image will obstruct you from here. But never mind. The word is M-A-T-H. That is the first word I can arrange. Then I can also arrange it like this. Having M-A, then H-T. That means I interchange the position of H and T. It's also a different arrangement. So I've gotten 2. I can still keep M being the first, H-A-T. Also be another arrangement. And this can continue. Having M starting can even perm 6 times. Then having A starting can also perm 6 times. Having t starting can perm 6 times, and then h can also come in for 6 times. In all together, we have 24 ways of arranging the word math. That is, having 4 letters and none of them is repeating can be done in 24 ways. So if I have one item, when we saw one item, we saw only one way of doing it. If I have two items, we saw that we had 2 ways, and 2 can be written as 2 times 1, right? It's same as 2. If I have 3 items, we saw 3 items gave us 6 ways, and I can write 6 as 3 times 2 times 1. I want to create a pattern for you to observe. Then 4 items like the math that we did, we had 24 ways, and 24 is the same as 4 times 3 times 2 times 1. So it means that when I had 4 ways, I start with 4, then 3, 2, 1, and I'll get the same answer as this. If I had 3 ways, I start with 3, 2, 1, then I get the same. So it means if I have 5 items, like maths, when I add s to it, it will give me 120 ways of arranging. And it will also be a pattern like 5 times 4 times 3 times 2 times 1. Please, are you making sense with this arrangement? So the number of items involved, if it involves 8 items, then I'll start with 8. Alright? Then if it involves 7 items, I'll start with 7. Then I'll multiply series of them until I get to 1. Now this pattern of multiplication is what we refer to as factorial. And the symbol is there. You see something like I, small letter I being subassorted. Alright, so that is it. So what happened for 8 different items? For 8 different items, you are going to have 8 times 7 times 6 times 5, and that will give us 8 factorial, and 8 factorial will be 40,320. So that is the pattern. So what if I have n different items? Then I'll go write n times n minus 1, because if it is 7, we'll say 7 times 7 minus 1 is 6, times 7 minus 2 is 5, 7 minus 3 in that order. So the same thing applies here. Then the question is, if this thing continues, what will be the last number? It will be n minus what, or times what? So if your answer is 1, then it means you are right. The last will be always 1. We saw that earlier, so that if I have 7, it will be times 6 times 5 times 4 times 3, and until I get to 1. So that is that. So that becomes our n factorial. So in general, write this fast down. In general, the number of ways of arranging n different objects in a row, no repetition, is always given as n factorial. And this can be written as n permutation n. And the n permutation n can be picked from your calculator. And then even the factorial 2 is on your calculator. If you look at shift and then the key that has x to the power -1, and at rate you see the factorial. So if you press shift and you press that key, this key, you can get a factorial there. Now note something here quickly, that 1 factorial is always 1 and 0 factorial is also 1. And this is amazing, that 0 factorial is always equals to 1. It doesn't make sense, but that is it. Because if you say 2 factorial simply means 2 times 1. So 0 factorial ideally should have been 0 times 1, but it's 1. And if you want to prove this, there's a proof for it. Let's assume that I have n factorial. I will know n factorial is always equals to n times n minus 1 factorial. I mean, let me explain this further. If I have 8 factorial, sorry for that. If I have something like 8 factorial, it's the same as 8 times 7 times 6 continuously. It's the same as saying 8 times 7 factorial. Do you agree to that? Very important to take note of that. If I have 5 factorial, it's the same as 5 times 4 factorial. All right. So if that is true, then we can say n factorial is equals to n times n minus 1 factorial. If I try to make n minus 1 factorial the subject of this relation, then I can write it as this. It makes sense, right? Good. So if that is true, then if I assume that let n be equal to 8 and I substitute 8 into this statement, I could have 8 minus 1 all factorial is equals to 8 factorial over 8. So, and I can also say 8 minus 1 is 7, and 8 factorial can be written as 8 times 7 factorial. So that when this and this cancel out, then we have 7 factorial is equal to 7 factorial, and that is true. So what it means is that the statement that we are saying that n minus 1 all factorial is equals to n factorial over n, that statement is true. So if we assume n to be 1, then we substitute 1 into that formula and says 1 minus 1 all factorial should give us 1 factorial over 1, right? So 1 minus 1 is 0 factorial, and 1 factorial is same as 1 divided by 1 will still give us 1. So therefore we can say 0 factorial is equals to 1, and that is the proof that 0 factorial is equals to 1. So that is that for this. So let's take some few examples and then we end this part of the video. So here, the first question you have here is, in how many ways can the word measuring be arranged in a row? And I'm sure you can pause the video and do this. That is, you count the number of letters involved and there's no repetition, so that will give us that total number factorial. So it will give you n factorial is equals to, which is the same as n permutation n, and the answer becomes 362,880. I'm sure you can do this one too. In how many ways can the word maths be arranged in a row? Pause the video and I'll give you the answer afterwards. Good. I'm sure your answer came as this. Then the last example for this, that should be example number 3. In how many ways can the word Christabel be arranged in a row? Christabel. No repetition. Can you see that? All right. I'm sure your answer is correct. So with this, we come to the end of this section. The next video will continue with repetition. Thanks so much for watching.